Well friends, now let's deal with the next parameter, which is voltage regulation. Guys, what is regulation? We've never came across such topic till now, and this term we've never understood. I mean, we must have heard it, but we must not have understood it till now. You're in second semester, guys. So let us understand what is regulation and why it is required. Voltage regulation hota kya hai? Guys, in BEE we have studied practical sources and ideal sources. So ideal source was having this characteristics. This is V, this is I. Whatso amount of current you draw from the source, it is not going to reduce the magnitude of that particular source. Fine, voltage ka magnitude will remain the same. Fine, that was ideal source. And practical source, you must have seen there was some resistance introduced. So as current increases, what happens? Plus minus voltage drop occurs over here, and this minus this will come across this. So as current increases, we can say the voltage slightly reduces. So this is where the regulation comes into existence. Fine. So this is ideal one and this is practical one. So we can say that if load is this much, suppose load is this much, this is 100% load, suppose this is 100%, this is 50% load. Fine, okay, 50% load, 100% load, sir pata nahi chal raha hai. You consider this is 10 ohms resistor, fine, and this is 5 ohms resistor. I'm sorry, this is 5 ohms resistor and this is 10 ohms resistor. This is 5 ohms resistor, which is 100% load. This is 10 ohms resistor. You consider this, if at all, this is 1 ohm and this is 10 volts, and if I connected 10 ohms over here, fine, if it is 10 ohms, let us say this is 100 ohms and this is 10 ohms, fine, this is 100 ohms and 10 ohms. So if it is 100 ohms over here, what will happen? What is the value of current flowing through this particular load? So 10 divided by 100 plus 1, it's 100. Approximately 0.1 ampere current is flowing. 0.1 multiplied by 1 ohm. So what is drop? 0.1 volt ka drop. So 10 minus 0.1, 9.9 voltage will come across 100 ohms resistor. But if the same case happens, plus minus, and we are having 1 ohm and we have connected 10 ohms resistor over here. So what will happen? 10 divided by 11. Now 1 is not negligibly small, fine. So it is like 0.99 say ampere current is flowing. So 0.99, here only 0.1 ampere current was there. Almost 10 times more current is flowing right now, fine. So we can say 0.99 multiplied by 1 will be what? 0.99. So it is 0.99 volts will come across this. So 10 minus 0.99, it is 9.01. So 9.01 voltage will come across this. You should never say that 100 ohm matlab zyada load and 10 ohm matlab kam load. No. 10 ohms matlab zyada load, 100 ohms matlab kam load. हैं? सर ये कैसा अजीब है? हैं? ऐसे कैसे? ये ज्यादा दिख रहा है तो बोले कम बोल रहे हो, ज्यादा दिख रहा है तो बोले कम बोल रहे हो, कम दिख रहा है तो बोले ज्यादा बोल रहे हो, ऐसा कैसे हो गया? Guys, when I say about load, it is defined from the current it is taking. Fine, okay? तो यहाँ पे current ज़्यादा है, यहाँ पे current कम है. Eventually you'll come to know many things about it, but right now this is more load, this is less load. Do you understand why it is less load? Cause current is less. Cause current is less. Where is current? 0.1. Current is less. This is 0.99. ठीक है? पता चला current is very much high. This is यानी 100 मिली एम्पियर है, दिस इज 990 मिली एम्पियर. पता चला कि नहीं पता चला? 100 का और 990 कहां? So high current is flowing over here. Is it clear or not? So we can say that as current is more, we say that the load is more. Clear? Because load बढ़ता है तो load current बढ़ता है. Remember that. Okay. Current बढ़ा तो क्या हो गया? Voltage कम हो गया. क्यों कम हो गया? क्योंकि यहाँ पे voltage का drop हो गया. Fine. So I hope you understood. This is the practical problem, and the same problem we are having with our circuit. So now let us remember the circuit. The circuit is like this. We are having primary, then we are having secondary, then there's a diode, then there's a load. Okay, I have told you secondary resistance is there, forward bias resistance is there, and load resistance is there, and this is where I'm going to get my output voltage. So we can say that if I consider this no load is connected over here, बराबर, no मतलब zero नहीं, no मतलब it is open circuited. No, nothing is connected. Open circuited मतलब if at all I consider load over here, so RL is equal to infinity. RL is infinity, no current is gonna flow, whatever voltage comes here, the same voltage will come across this. So output voltage will become no load condition पे output voltage will be maximum Vm divided by pi. Is it clear? Fine. But the moment I'll be having something which is not infinity, matlab full load, if I say full load is RL, so what will happen? Current will flow. Fine. How much amount of current will flow? So I, which is equal to IDC, which is equal to VDC divided by total resistance RS plus RF plus RL. This is my IDC. So what will be my VDC? So VDC. Current was VDC is equal to IDC multiplied by RL. IDC multiplied by RL. So we'll be having, so first case maybe we have not considered it. The reason is that my current was zero. Fine. My current was zero. So I can say that right now current was zero. So we can say the entire voltage will come across it. पता चला कि नहीं पता चला? अभी कितना वोल्टेज आएगा? सर करंट जीरो है तो RL मल्टीप्लाइड बाय IDC इज इक्वल टू जीरो नहीं हो जाएगा? नहीं, गलत बात है. क्यों गलत बात है? बिकॉज वोल्टेज इज गोइंग टू कम अक्रॉस इट. फाइन, वोल्टेज इज गोइंग टू कम अक्रॉस दिस. सर ऐसे कैसे? करंट जीरो तो वोल्टेज कैसे आएगा? अरे यार, यहाँ पे पीछे सॉकेट पड़ा हुआ था, अभी दिख नहीं रहा है, पर अपने घर पे वो सॉकेट के अंदर हम जब प्लग डालते हैं तो ऐसा मान, प्लग डाला तूने, दो वायर निकल रहे, तेरे को लगेगा तो करंट लगेगा ना तेरे को. अभी देख ऐसे पकड़ के रखा है तब करंट नहीं उसके अंदर. इट इज ओपन सर्किटेड. फाइन, ये दो वायर अगर मैं कुछ नहीं लगाऊंगा, इट इज ओपन सर्किट, द वायर्स आर ओपन सर्किटेड, बट व्हाटएवर वोल्टेज इज कमिंग देयर, वोल्टेज इज कमिंग ओवर हियर. अगर टच करेगा तो करंट लगेगा, मतलब वोल्टेज इज देयर. पता चला कि नहीं पता चला? मैक्सिमम वोल्टेज इज गोइंग टू कम एट दैट टाइम. पर जैसे ही तू लोड लगाएगा, ड्रॉप होना चालू हो जाएगा. क्लियर हुआ कि नहीं हुआ? सो लोड लगाया, RL लगाया, क्या हो गया? करंट आ गया तो अभी कितना वोल्टेज आया? सो IDC मल्टीप्लाइड बाय RL. व्हाट इज IDC? सो VDC divided by RS plus RF plus RL. So when my full load is connected, my full load voltage is this much. So VDC is what? VDC is equal to Vm by pi. याद है ना, average voltage. So we can say that it is equal to multiplied by this is IDC multiplied by RL. So VDC is what? Vm divided by pi into RL divided by RS plus RL. Fine. So this is my full load voltage. Fine. अच्छा, नो लोड पे वोल्टेज ज्यादा होगा, फुल लोड पे कम हो जाएगा. क्यों ऐसा? अगर नो लोड है, लोड ही नहीं है, यहाँ पे करंट नहीं आएगा, तो यहाँ पे जो भी वोल्टेज है सीधा वोल्टेज यहाँ पे आ गया. फाइन, ओके. डीसी वोल्टेज कंप्लीट, यहाँ का वोल्टेज यहाँ पे नहीं बोल सकते, यहाँ पे फुल वोल्टेज आ गया. फाइन. पर जैसे ही करंट आना शुरू हो, व्हाट विल हैपन? I इंटू RS का ड्रॉप होगा, IDC इंटू RF का ड्रॉप होगा, तो इन दोनों ने खा लिया, उसके बाद जो बचेगा मेरे को यहाँ पे मिलेगा. इज इट क्लियर? फाइन. सो वी कैन से दैट फुल लोड व्हिच इज इक्वल टू Vm डिवाइडेड बाय पाई RL अपॉन RS प्लस RF प्लस RL. सो मतलब क्या हुआ कि वोल्टेज रेगुलेशन पिक्चर में आया. सो व्हाट इज परसेंटेज वोल्टेज रेगुलेशन व्हिच इज इक्वल टू परसेंटेज रेगुलेशन V नो लोड तब ज्यादा है माइनस V फुल लोड अपॉन V फुल लोड विथ रिस्पेक्ट टू फुल लोड. वी आर कैलकुलेटिंग मल्टीप्लाइड बाय 100% fine. Okay, so V no load is what? Vm by pi. So it is Vm divided by pi minus it is Vm divided by pi multiplied by RL divided by RS plus RF plus RL divided by V full load. Full load is this Vm divided by pi into RL divided by RS plus RF plus RL. So we have got this thing Vm by pi कॉमन एंड कैंसल्ड, ये एलसीएम से यहां पे आ गया. So I hope you are understanding. So we'll be having RS plus RF plus RL minus into 100 है भाई into 100%, RS plus RF plus RL minus RL divided by, say denominator is cancelled with this denominator, so I'll be having only RL over here. So this is cancelled, multiplied by 100, comes out to be RS plus RF divided by RL into 100%. So this is my percentage regulation. Ideally what should be regulation? फुल लोड हो या नो लोड हो, वोल्टेज शुड नॉट चेंज. समझ पड़ा कि नहीं समझ पड़ा? वो पूरा लोड चढ़ गया उस सप्लाई पे, या तो लोड है ही नहीं, फिर भी क्या वोल्टेज तो सेम ही रहना चाहिए. फाइन, ठीक है. ये तो क्या, तू 2 बल्ब चालू कर तब वोल्टेज कम होगा, 5 चालू कर तो वोल्टेज बैठ ही जाएगा. नो नो नो, दैट इज नॉट डन. फाइन. सो हियर आइडियली क्या होना चाहिए? रेगुलेशन शुड बी 0. मतलब नो लोड माइनस फुल लोड अगर 0 हो गया मतलब नो लोड इज इक्वल टू फुल लोड. Fine. Voltage should not change. Is it clear? So we have understood what is percentage regulation. Fine. Write down.